If you've never heard of Mqtt, I don't blame you. It's been only a year since I was first confronted with it. But here's the clue. You probably already know most of how it works if you've ever worked with OSC. But let's take this step by step. Mqtt is short for Message Queuing Telemetry Transport and is a machine-to-machine communication protocol for the transmission in environments of high latencies and flaky networks. Why is that interesting? Because Mqtt is the standard protocol for IoT applications, the Internet of Things heartbeat, so to speak. Chances are, if you have any smart home or sensor devices at home, they already transmit or offer Mqtt at some endpoint. So here's an opportunity for a wide range of sensor and actor integrations, which can be a great source for various artworks. So this is how Mqtt works on a basic level. It's a publication subscription system. Client A subscribes to a certain topic, and Client B publishes that topic. Between them, a broker is responsible for handling the passing of messages from publishers to subscribers. As you can already see, the message syntax is very similar to OSC. With Node.js, we have a powerful tool at hand to actually deal with such protocols and integrate them into installations or performances. Let's first npm init a project. Next, we'll install the Mqtt npm module. We'll make two separate JavaScript files here, one named mqtt-subscriber.js and one named mqtt-publisher.js, respectively. In the next patch, let's load them into Node script objects and ponder how we'd like to communicate with them. First of all, we need to connect to a broker, which will be running on our localhost machine for testing purposes, so we send a connect message to the object. Next, let us simulate a sensor transmitting data, pool temperature for example, with a metro and a drunk object. So here's the thing, we're not actually setting up a sensor, we're using our max patch to emulate one. As for the subscriber, we'll also need to connect it to that same broker and then subscribe to that temperature pool topic. So how do we get the broker running? Well, the easiest way is to use Docker for that purpose. From the Docker Hub, you can download and run the Eclipse Mosquito image like so. If you'd like to learn more about how you can leverage Docker for your projects, I've got a full course covering it over at dockerforcreators.com. Suffice it to say here that we're exposing port 1883 here, which is the standard Mqtt port. This Docker container will then be responsible for handling subscriptions and relaying published messages to the subscribers. Now let's start fleshing out that publisher. We import the Max API as always, plus Mqtt. We add a connect handler and use it to instantiate a client. On it, we register a listener for the connect event, and just for testing purposes, we'll post a message to the outlet. Let's see if that works. It does, and the broker also logs out this new connection. Next, we add a publish handler for our node script object. In it, we just console log the topic end value for now. Okay, we have undefined arriving here. Let's see. It turns out I've misused the $1 notation here, when what I actually need is a prepend object. Now this looks better. In the other file, we add a subscript handler and subscribe to the incoming topic. When a message arrives, we output this via the max objects outlet. And here's the point where I finally realized that I've done it all backwards. Of course, I need to put the subscriber's code into the Mqtt subscriber.js and the publisher's code into Mqtt-publisher.js. Okay, now that that's sorted out, I need to actually cast the published message to a string. And do the same for the incoming message, otherwise the console will try to print the raw binary data. Now this looks correct. Imagine we had just connected a bunch of sensors to a Max patch and can now start making interactive visuals, sonifications, or what have you. How cool is that? There's just another small feature of Mqtt I'd like to point out. Let's say we're actually sending the temperature of the first pool by appending a /1 to the topic. Subscribing to our old topic now won't yield any messages, obviously. Let's verify that everything still works by using that same topic. Mqtt allows for two types of wildcards basically. A hash at the end of a topic recursively subscribes to all subtopics of that topic. A plus in the middle of a topic will act as a wildcard for that subtopic level, in our case pool. This subscription would also listen for temperature/roof/1, for example.